In this video, we'll be looking at how to use definite integration to work out the areas of shaded regions. So first, let's have a recap about definite integration and the geometrical significance of it.
So the first thing we need to think about is the geometric significance of a definite integral. So if I have this integral between the limits of a and b, then my definite integral is going to calculate the area enclosed by the graphs of y equals f of x and the lines x equals a and x equals b. So I literally draw a line down from the line f of x to the bound on my x-axis, and between those two lines and my original curve, that's the area that the definite integral calculates. So that's what we need to remember when we do these questions. We need to think about what the actual integral is calculating, draw those lines down, shade that, and then use that to work out whatever the area is that the question is asking us to calculate. So the other complication is that if the curve is below the x-axis, then the integral will give us a negative value. But the area that we want is actually positive. And if we have areas above and below the axis, like in the diagram, then when I calculate the definite integral, so if I calculated the definite integral between c and 0, the parts below the axis would start to cancel out the parts above the axis, so I'm not going to get the right area. So if I have parts above the axis and below the axis, I need to evaluate each part separately. And what I need to do is I need to change the sign of the part below the x-axis because that's negative. So I can take the modulus of that, and that's what I've written at the bottom. So I need to take the definite integral between 0 and a, then the definite integral between b and a, but I know that's going to be positive, so I take the modulus of that to make it positive, and then the definite integral between b and c. Add those all together and that will give me the total pink shaded area.
So now we're going to go through a number of examples of different kinds of questions that you can get where you're needing to find the area of a shaded region.
So in this first example, this is probably the simplest case. So I'm going to look at this question. I need to find the area of the shaded region enclosed by the curve, the x-axis, and the lines x equals 1 and x equals 3. So if I write down my integral, the integral between 3 and 1 of f of x, and I go to my diagram, I draw down to my lower bound, which is 1, and I draw down to my upper bound, which is 3, and I shade that. That is what the definite integral is going to give me. And that is the same as the shaded area in the question. So I know that this integral is going to give me that area. Now, you know that we can do this by our calculator, so I can write by calculator and do it that way. Or we could do it by hand, which is what I'm actually going to do because that's probably good practice anyway. So what I'm going to do is work out the indefinite integral first by doing increase the power by 1 divided by the new power. But I don't need my constant of integration because I'm doing definite integration, and then simplify. And then I need to substitute in my bounds. Put that on my calculator. And then I write units squared because this is an area. Okay, example 2. So again, this is the simplest case, but instead you can see that our area is below the x-axis. So let's work through the question. So in part A, I need to find the coordinates of the points where the curve crosses the x-axis. So to do this, I can put my function equal to 0 because y is 0. And then I can factorise. And then it asks me for coordinates, so I need to write it in coordinate form. And that's my answer. Part B, I need to evaluate this integral. You can do it by calculator or we can do it by hand. Let's do it by hand. Now simplify. Then stick that in my calculator. End up with minus 27. Part C, state the area of the shaded region enclosed by the curve, the y-axis and the positive x-axis. So I've already evaluated the integral between 0 and 3. I know the point where this crosses the x-axis here is 3 from part A. So I draw my line. There's obviously not a line there because it's crossing. And I draw my line from the origin, which is my lower bound, to the curve. And then it's in between those lines. So it's that part. So it's the whole of the shaded area. So I know I just need to make my part from B positive. And then put units squared because I know that it's an area. So in example 3, we've now got the case where we've got a shaded area above and below the axis. So in the first part of the question, I need to find the points where the curve crosses the axis. So I put my function equal to 0 because where I cross the x-axis, I know that y is equal to 0. I can take an x out first. And then I can factorize. And it's asked for coordinates, so I need to write them as coordinates. Now for part B, show that the total area of the shaded region is this value. So I know that these points are my coordinates, and I've got an area above and an area below the axis, and my area is completely enclosed by the curve, the x-axis, and my points. So I need to work out this area separate to this area. And I know that this one is going to be negative. So what I need to do is I need to work out the integral between 2 and 0 for my function. And then add on the modulus of the part that will be negative, which is the integral between 3 and 2 of my function. So I can work that out by calculator. In this fourth example, I've got a shaded area between a curve and a line. So the first thing the question asked me to do is to find out the coordinates of the points where the curve and the line intersect. So I know that where they intersect, the curves are equal to each other. So I end up with a quadratic, which I can factorize. And then I can put this into my y. And then I need to write down the final answer in coordinate form. So I know these coordinates now. Now I need to look at finding the area of the shaded region. So I know that this x value is going to be 1 and this x value is going to be 3. Now, if I work out the integral between 3 and 1 of my curve, then I know that that's going to give me this part under the curve in between my lines, which isn't my shaded area. So what I need to think about is this trapezium here. Now, you know the area of a trapezium is a half of a plus b times h, where h is the perpendicular height and a plus b are our parallel sides. So let's say that this part is a. Now, I know the y-coordinate of this is 2, so I know that this length is 2 because I'm going from 0 to 2. In the same way, I know that this length is 4 because I know that the y-coordinate of the intersection at that point is 4. Then I need the perpendicular height, which is going to be this part, which is the difference between 3 and 1, which is 2. What I also now know is that my shaded area is the area of the trapezium minus my integral. So I can work that out. I'm going to say that I've done it by calculator. So I know that my shaded area is just 4 over 3 and it's an area, so I'm going to put units squared. Okay, so in this example, you can see that we've got a sort of vertical area. It's to the left of my curve. So the first thing the question asks me to do is to evaluate this definite integral. So I'm going to do it by hand this time. So I know that this is equal to the integral between 2 and 1 of x, 8x to the minus 3. So what I need to do is increase the power by 1, divide by the new power. Okay, now for part B. The first thing I'm going to do is think about what my x value actually is at these points here. So when y equals 8, I know that x equals 1. When y equals 1, x equals 2. So if I think about what my integral is actually giving me, I draw this line down to 1 on the x-axis, and I draw this line down here to 2, and it's giving me this shaded area here. So if I want the shaded area in the question, what I need to do is I need to take my integral and I need to take away this rectangle here, which I know if that is 1 and that is 1 is area of 1, and I need to add on this shaded area here, and I know that that part is 1, that part is 7, so that has an area of 7. So what that means is I know that the shaded area is my integral, take away 1 plus 7, which is 3 minus 1 plus 7, which is 9. I'm going to put unit squared because I know it's an area. In this example, you can see we've now got a vertical area, we've also got a curve, and we've also got a line. So we've just kind of upped the ante a little bit. So the first thing we need to do is find the equation of the normal to the curve at point P. And I know that point P is 1, 3. So let's give myself some space first. So if I want the equation to the normal, the equation of the normal of the curve, the first thing I need to do is find out the gradient of the curve at that point. So I need to find out my dy by dx. So I differentiate the equation for the curve. And I know that I want the gradient at my point P, so when x equals 1, and I find the gradient, which is also 1. Therefore, the gradient of my normal is the negative reciprocal of that, which is minus 1. So I know the equation of my normal is something like this, but I don't know my y-intercept. I need to sub in point P to find my y-intercept. So I know C is 4. Therefore, the equation of the normal is y is minus x plus 4. So the shaded region is bounded by the curve, the normal to the curve at P and the y-axis. Show that the area is this. So let's think about this. So I know that I can find this shaded area here. If this is my x-coordinate 1, I can find this shaded area here by doing integration. That would be my integral between 1 and 0 of my curve. What I can also do is find the area of this whole trapezium. And if I take the integral away from the area of my trapezium, I'm going to end up with my shaded area. So, I know the shaded area is a half. If I think about what my parallel parts of my trapezium are, I know that this y-coordinate here has to be 4 because of the equation of the normal curve, and I know that this y-coordinate is 3 because of my point P. So I know I've got a half of 4 plus 3 because those are the lengths of my parallel lines, and then I know this is 1, so times 1 for the perpendicular height of my trapezium, and I need to take away my integral between 1 and 0 of my curve. Stick that in a calculator. Stick that in a calculator. And I should write by calculator. And that gives me that the shaded area is 5/3. And I write unit squared because it's an area. Okay, so this is the last example. And we can see we've got, instead of in the previous examples, we've now got a curve and a line, but we've got the area above the curve. So let's give some space. So the first thing we need to do is find the coordinates where our curve crosses the x-axis. So I know it crosses the x-axis when y is equal to 0. And then I need to write in coordinate form because they've asked me for that. Okay, so now it tells us that the line has this gradient and it intersects with C at points P and Q. Find the coordinates of Q. So I know that my line is going to be something like this. And I also know that when y equals 0, that x is equal to 2 because it crosses at point P. So I can stick that in. And that gives me that c is equal to 6. So I know that this is the equation of my line. So now I need to find where the line and my curve intersect. So I need to put them equal to each other. Now I've got a cubic here, but I know that they both cross at point P. So I know that x minus 2 is a factor of this. So then I can do some polynomial division. So I'll change colour to try and make it a little bit clearer. So what do I need to multiply x by to get 3x cubed? It needs to be 3x squared. I'm actually just going to edit this because I don't have a x coefficient. So I'm just going to put plus 0x in there so I remember that. So I end up with 3x cubed minus 6x squared. I'm going to take that all away. So I'm going to end up with minus x squared here. I bring down my plus 0x. So what do I need to multiply x by to get minus x squared? It needs to be minus x. I end up with minus x squared plus 2x. And I'm going to take that away. So I end up with minus 2x here. Bring down my plus 4. So I need to multiply x by minus 2 to get minus 2x. End up with that. And that's all done. Just give myself a bit more space here. So then I know that I end up with this. And I can factorize that. So I know that the x equals 2, that is p, but I also have x equals minus 2 over 3 and x equals 1. I look back at my curve. I can see at point Q that I've got a positive x value, so I know that x equals to 1. I can stick it back into my equation for my line to find y. I know that that's 3, therefore Q is the point 1, 3. So now I need to find the area of the shaded region. I actually need to show that it's a half. So let's zoom in on here. So I know that this is point 2, and I know that this is 1, 3. So if I work out the integral of my function between these 2 points, I'm going to end up with this shaded area here. So to find the shaded area I actually want, what I need to do is I need to take away that from this triangle. I can use a half of the base times height, because I know that this is going to be 3 because of the y coordinate q. I know that this is 1, so I know that this is 1. So I know that the shaded area is the area of the triangle. Take away the integral between my two x coordinates of the curve. Again, I can do that by my fancy calculator. And I end up with a half. And I'm going to put units squared because it's an area.
I hope you found this video useful, and let me know if you have any questions.